This is the experiment of Qpsk, quadrature phase shift keying, modulation and demodulation. Just refer to this table initially which is given here. So for 0 0 it is given as 0 degree, for 0 1 is 90, 1 0 is 270, 1 1 is 180 degree. So according to this bit pattern you'll be getting the phase shifted output. Okay, so now we'll look into the connections. So firstly you'll have a power supply. In the power supply you'll have a pin like this. So this pin has to be connected in proper alignment to this knob and it has to get fixed. Okay, then for this one, see here, this is the data input, right? So in the data input you're having, this is our MSB bit. Okay, then this is our LSB bit. So this side if you keep, it is high, bit 1, or if you keep 0. So if I keep everything on the left hand side, everything is 0. So now only LSB is 1. So like this you can keep any data pattern what you want to send or transmit. So now we have to connect the serial data output inside this splitter. Okay, this is the first one. Then this is getting splitted as even bits and odd bits, like B of 0, B of 2, 4, 6 till there are even bits, and similarly B of 1, like 1, 3, 5 and 7 are odd bits. It will come here. Okay, so now connect this even bits part to something written as even over here. Then similarly this odd to where odd is written. Okay, now here you are having the sine wave carrier generation. So there are four things, right? Connect the sine 0 to this sine 0 where it is 0 mentioned. Basically the first one is connected to this first one. I'll just use as a wire. Yeah, the first one to the first one. Then sine 90 to here sine 90, basically the second one to this second one. Then 180, which is the third one, to here 180, this is the third one. Then here 270 to the last one, 270. Okay, then here this is the modulator. Here you'll be getting the modulated output. Connect the modulated output inside the demodulator. Okay, so that's it, is the wiring now. So now we'll have to take the probe. So connect the one end at this ground point like this. So ground is mentioned, right? So this becomes the ground. So take another pin, connect it at the demodulated output. Okay, then in order to have a reference signal, we'll connect another wire at this serial data input or this output. Any of these 2 points are fine in order to have a reference of message signals. So this is the overall connection. So first I'll show you the modulated wave. So for that we'll just keep this red one in the output of the modulator. See here output Qpsk Kit written here, right there. Then just make sure that you turn on this power supply. You should get a light over here. Then for this corresponding bit pattern from MSB, so 1 and 1 is there, right? So it will start from 1 and 1, it is starting at 180 degree. So like that you have to notice that. So this will be our message signal, the yellow color one, which is connected to channel 1. Channel 2 is our Qpsk waveform. As per the message we will get the Qpsk waveform. Then we'll remove out here. I'll connect it at this demodulated output point. So when you see here, you'll be getting a slightly delayed version of the same output. So that's it as this experiment. In case if you want to notice the even and odd bits, instead of connecting over here, connect it at this even point. You can see something written as even, right? There you connect this one. So you'll be getting to know all the even bits, 0, 2. It will be coming for 2 time clock pulses. Okay. Similarly you can do it for odd bits, and then the demodulator you just verify. You should get the message. That's it. And you can vary these things.